Hey everyone, we are going to have an introduction to limits. So here are the first rules of limits. 1, think less, not more. I'm not joking, sadly enough. 2, don't overthink it. 3, squint at it. What's essentially going on? Step 4, see rules 1 and 2. I mean it on those rules. Okay, so the deal with limits is really comes down to this. What value does y get close to as x gets close to blank? So that's the weird thing. You're not technically equal to an x value. You're just getting arbitrarily close to it. You're just getting as close as you feel like getting to it. Like, you're not talking, when we say x arrow 1 here, this limit notation, you're going to get used to it a lot. But when you see that lim x arrow 1 f of x equals, what you're saying there is, what value of y, what value does y get close to as x gets close to 1? So we're looking at like when x is 0.9999 or 1.0001. We're saying get close to 1. You kind of squint at things and you go, what value is y getting close to? This question is the thing you have to ask yourself repeatedly here. So looking at our graph here, as x gets close to 1, I approach from either side of it, I can see that y is getting close to 2. So the limit as x approaches 1 is 2. By the way, this guy has a name. It's called, oddly enough, a hole. It's also called a removable discontinuity. Okay, moving on. So the limit as x approaches 2 of f of x, so approaching 2, I can look at this and go, oh, as x gets close to 2, y gets close to 3. There's my limit. Now here's the weird thing with limits, and this is why the confusion sometimes happens. Like in this, like in the case of x equals 1, like f of 1 is undefined. There is no y value for f of 1. But f of 2 is 3. And to be honest, I don't care. I don't care if f of 1 is defined or not. I don't care if it's equal or not. I don't even care if, going back to like if f of 1 was filled in and there was a point up here, like say we had that guy and f of 1 equaled 3, I still don't care. The limit as x approaches 1, whether or not that point is there, the limit as you get really close to x equals 1, y gets really close to 2. Who cares whether or not that point is there? In fact, I'm going to erase it again. Doesn't matter. Looking at x equals 3, or x approaching 3. As I get close to 3 from either side, my y value gets close to 4. Do I care that it's pointy and weird looking there? No. I just ask myself again, what value does y get close to as x gets close to 3? Okay, moving to, and by the way, oh, the name of that guy, this is a cusp or a corner. I'm going to throw a lot of vocabulary at you today. Okay, looking at x approaching 5. I'm going to slide my paper up. So the limit as x approaches 5. I'm still keeping this question in mind. I'm going to move it so we can still see it. But as x gets close to 5, now this is a problem. From the left side, like heading from 4, I can see that my y value is heading towards 1. But from the right side, I'm heading close to -1. So the limit as x approaches 5, because my left side and my right side aren't going to the same place. This is a mean girls limit. The limit does not exist. And we usually just write D and E because mathematicians are efficient, lazy, whatever. So, but really it means does not exist. looking at the limit as x approaches 8. Oh, going back to here for a minute. This guy right here, it's called a step. And still with f going to 5, I don't care that f of 5 is -1. I don't care if f of 1 didn't exist at all. I don't care about, sorry, I said that wrong, 5. I'm talking about 5. I don't care whether or not f of 5 exists. I don't care if it, I don't care. I care about what's happening as I get close to 5. That's the main thing. Looking at 8, I have a vertical asymptote here. And because the left side is going to -infinity and the right side's going to positive infinity, my left and right side aren't going to the same place. So this guy does not exist either. So if you have an equation, plan A is always going to just be to plug the number in, even though it's kind of a cheat. But because remember, the question is, what value does y get close to as x gets close to whatever number? Well, the number itself is pretty close, isn't it? So it's kind of the cheat we do, and that's okay. So plan A, if you have an equation or even a function, you know, just looking exactly at the point itself. But we have to look at the sides of it and make sure that the left side and the right side are going to the same place. And so when I talk sides, like literally using my hands, like I can use my left hand on the left side as I approach 1, and I can use my right hand as I approach 1 from the right. That's going to come back again later. But for now, this is your first introduction to limits, and the main thing to keep in mind is this question right here. The other thing to keep in mind is the rules of thinking less, not more, and not overthinking, and squinting a little too.